Try to cast. Oh, okay. Okay. Why is Bang Kaijun over here? Hello, Kaijun. Evening, good evening. Hmm. Well, yeah, I mean, the live states that today I'm doing a year 9 recap on acid bases and salts. By the way, welcome to the stream. Not sure whether any of the year 9s will actually show up, but we're gonna hope that they do. And yeah, I mean, I don't have music to put on unless you have suggestions. So yeah. Yet then one I'm planning, I'll be informing Kason when I'm gonna do it. So you have to stay tuned. I probably should mess. Most likely, yeah. I'm not too sure when I'll have some time to do it, but I'll try and do it. Probably not this week, maybe next week. Do you want me to book Hairen? If he doesn't want to check it out, then he can don't check it out, honestly. So yeah. Oh, all right. So wrong slides, right? Mm. Anyway, how is your holiday, Kaijun? So good. Haven't started doing my homework lah if it's so good. Mm. No homework. Oh well, it's fine. We'll get back to it when we get back to school. Either way, sit back and relax. If you have a cup of matcha, you can drink a cup of matcha. If not, well, I'm not drink. I finished my matcha early in the morning. Nah, you know. Let's see. The chemistry. All right, chemistry. The paper force. Have you forgotten? The one that I gave each and every one of you a set. Didn't I ask you to at least look at the question? It's the question trees. Or the question force and ask you to do. And then at maths was the plus what I gave in school. At least I remember giving you guys the work. I'm not sure you guys registered in your brains. But hopefully you did. Well, hopefully is a very big word, but yeah. Okay. When was oh well. Hmm. At any rate, if you are here on the stream, welcome, welcome. It is an evening and a bit later than I expected to stream. But hey everyone, this is Matcha Sensei. This is for people who are new to this channel, I am a chemistry and additional mathematics teacher who has a bit of an unhealthy obsession with Japanese green teas. So uh, I like to This is why the name of the channel is Matcha Sensei. I teach chemistry and additional mathematics for IGCSE, with the goal of making sure that people understand and have the flow of learning their subjects and ensuring that they're just not just memorizing stuff, but they're also learning the process. So today is a year 9. It's a quick recap for specifically for my year 9 students on the specific topics of acid and bases and salts. Today the goal is very simple. We will be looking through I'll be doing a very quick recap for some of my students who might be new to chemistry, to give them an overview and to also outline what topics that they all need to learn before they actually attempt. It's also a bit of a guide for you guys. And then I'll go into the main topics, which is going to be acid, bases, and salts. We will be looking at what are acids, what are bases, and also discussing some of the interesting um, reactions that you need to remember. Also, I'll be covering some stuff that I did not cover in class. So if you're here, strap in, grab a cup of matcha you have, and let's lock right in. Uh, Either way, this is going to be a 1 hour stream if anyone's watching, and I hope that you guys follow along and stay lively. So I'll try and check back. I'm not a big guy on checking on the stream, but I'll try and check back every time I finish a certain subsection so that we try and get some questions going. So without further ado, I'm going to switch into so what we'll be doing again is going to be focusing on let's see. So we will be focusing on using word in this case. So it's going to be an old school style. So without further ado, let's get right into it. So I think about chemistry, right? People think of chemistry as this really hard topic, especially if you're starting off in IGCSE year 10 or year 9. You'll think that first thought about chemistry module is that why is it so complicated? Why does it sound so alien? And a lot of it is because when we talk about chemistry as an overview, it is one of the most in-depth sciences that you need to know, but it is the key and the foundation of all other sciences. When we talk about chemistry, we are talking about the study of the atoms, of the basic units of matter, namely atoms, particles, and all that, and everything that is made out of atoms, of and comes from atoms, from them. And in essence, I always say that chemistry is the king of the 3 sciences. Without chemistry, you cannot have physics, you cannot have biology. Of course, as a chemistry teacher, I might be a bit biased, but hey, you can't fight with truth. So I talk about chemistry, I just like to highlight a few things. The first thing is the basics of chemistry, and then what I'll call is the 3 fields. The three fields of chemistry. Now, the 3 different sections of chemistry that you need to focus. So, the top basics of chemistry, I'm talking about things that the chapters that you really need to know. And if you find yourself really struggling in the 3 fields of chemistry, but you do not know the reason, it's most likely is that your basics you have an issue in understanding your basics. So, on the basics of chemistry, we have to talk about the subatomic particles. When we talk about subatomic particles, I like to use the PM, which stands for protons, electrons, and neutrons. Understanding why these 3 subatomic particles are important are very key to understanding everything else. It affects the next topic that we learn, which is chemical bonding. Chemical bonding, there are 3 different types. I'm just going to focus on the covalent, which are covalent, ionic, and metallic. It also affects, and based on that, we get the chemical formula. In addition, you'll need to know how to read the periodic table. You need to understand the trends. You need to understand the various, and you are given the four major groups / supergroups in terms of that you learn in the periodic table. Finally, you will need to know your experimental technique. So experimental technique means your separation techniques as well as your lab techniques. as well as your laboratory apparatus. So in order to actually be somewhat able to grasp chemistry, you have to start from this. And I come across this so many times in class as well as in my interactions with students, is when you do not understand how chemical bonding works, chemical formula works, you're not sure how to name certain compounds, you're not able to actually think what type of bonding certain compounds have, you're not able to actually identify what are the how do electrons arrange, or how many protons and electrons, and how that affects the charges. You usually have a big problem in understanding how things work. And if you do not understand your periodic table, you do not understand which groups, what are the trends in the major groups of the periodic table, you'll also be unable to grasp the intricacies, especially when we come to reactions. So if you are struggling in chemistry, I really recommend that you go back to the basics of chemistry. Just look at what is important. You look at these things and you just focus on these things and make sure that you're clear about that. And then from there, then you choose one of the three fields. Now in the three fields of chemistry, I divide them into the three, which is physical chemistry, inorganic chemistry, and organic chemistry. Now, physical chemistry, if you want to give it a proper name, it is the interactions of matter in physical space. In other words, how does it interact in the three dimensions? So physical chemistry focus, first thing that you learn is the first chapter of your textbook most of the time, changes of state of matter, effect of pressure and volume, temperature and volume. And after that, you may go on to some things called chemical energetics, rates of reaction, chemical equilibrium. In terms of inorganic chemistry, usually what we focus on is chemistry involving non-carbon containing matter. This is so acids and bases, salts. Oh wait, did I not change my slides? Oh, my bad. Did I not? No, I can tell. I did, right? Yeah, I did. So acid, bases, and salts, metals, electrolysis, and qualitative analysis. And now for me, in my class, I choose to go with inorganic chemistry. That is just a little bit more on, I choose that, honestly, there's not much differences in terms of choosing which one to go first. I just like acid inorganic chemistry because it deals with a lot more chemical formula. It allows me to actually access chemical calculations, which is a good thing I didn't mention, which is chemical calculations over here, or sometimes known as stoichiometry. And inorganic chemistry has so many equations that it allows us to actually explore calculations in more in-depth. Finally, there's organic chemistry, which is the chemistry involving carbon-containing matter, often at times living things, and biological molecules. So things such as alkenes, alcohols, not alcohols that you're thinking about by the way, carboxylic acids, esters, and polymers. So when we talk about chemistry as an overview, we always start with the basics. You are having struggling, first get focused on the basics, then choose one of the following three to look at. Usually, I suggest that you actually start with inorganic chemistry or physical chemistry. both are equally good. Usually I leave organic chemistry a little bit later because it's again a little bit more memorization and patterns. But honestly, any tree is fine, just that I personally like to go in organic chemistry first. And when we talk about, so yeah, that's the basic overview of inorganic chemistry. Again, when we are looking at chemistry, it's very important to actually talk about, if you're talking about what websites or what do we say, or other YouTube channels that we do, I really like to shout out Cognito. Going to Cognito, they have a lot of 1 minute videos just discussing on GCSE chemistry, and they give very good um, summaries of the different types of each chapter that they actually explore. A lot of it being inorganic chemistry. Um, Also shout out a lot of different websites that you guys can view. Incognito is where I usually go to. So without further ado, right, let's go straight into today's topic, which we're going to look at is going to be acid, bases, and salts. Now, before I continue on, right, so before I continue on regarding these things, so when we're talking about chemistry, like, do you guys have any favorite topic, or is there any topic that you really don't like in chemistry itself? So I see Kaijun, and I think that that Bangjun and Potato. So I think I see a lot of my own students over here. So I mean, these guys have already completed the syllabus, so I really hope that they're doing. I hope I hope that they have done their topics justice, right? And so anyway, coming back to the topic on acid base and salt. Pang Jun really doesn't like cell matter, right? And and heads and shoulders, welcome, welcome. Not sure if this. So state of matter is actually a very simple topic. It's actually should have been covered a little bit in physics, but anyway, it's one of the easier topics that we actually can do. But I can answer some questions at the end, since the year 9s who will probably be watching this video and wondering why am I talking about year 10s, will probably also need a bit of a recap. So anyway, acid bases and salts. Usually I teach this in a single row because that's the only way it makes sense. So when we talk about acids, right, most of the time we define acids as substances that can donate protons, and when we talk about bases, we are talking about substances that can accept protons. Now, some books add an aqueous solution, but the idea, but this isn't always the case. What you have to remember is that and sometimes if you have good basic understandings of what acid is, you'll probably be thinking about what you'll probably be reminded that protons here are not referring to the protons in the atoms themselves. They are referring to the H plus ion. And the reason why we refer to protons, the H plus ions as protons, is because when we look at the distribution of protons in hydrogen atom, which is H, you will realize that in terms of protons, electrons, and neutrons, hydrogen only has one proton and one electron. It has 0 neutrons. So when we get hydrogen ion H plus, it loses electron, meaning that there is only one proton left. So oftentimes we will call acids as proton donors. Now there's always a difference. We must always split them into strong acids which are substances that donate protons completely, and keyword being completely, and weak acids are substances that donate protons partially. When we talk about completely and partially, now when acidity, in order to understand why we strong and weak acids are divided in this way, is because acidity of a solution is determined by the percentage of H plus ions released by the acid. Now, strong acids will donate their protons completely. In other words, if I have hydrochloric acid, which is always aqueous, when it releases hydrogen ions, it will release all its hydrogen ions in the solution. In this case, we are using solutions to show that it releases everything. This means that if I have 0.1 moles of hydrochloric acid, I will form 0.1 moles of hydrogen ions. In the case where I'm dealing with something with sulfuric acid, which can release 2 hydrogen ions, for every mole of sulfuric acid, it will release 0.2 moles because of the ratio. This means 100% of the hydrogen ions or the protons are released or are donated. This is a very important point. Well, weak acids, it's important to note that weak acids, we are taking an example of ethanoic acid or acetic acid, CH3COOH. What will happen is that in the reaction, even if you have 0.1 moles of CH3COOH, which is acetic acid, you'll get less than 0.1 moles. So you get less than 0.1 moles of hydrogen ions. So as long as you have less than 0.1 moles of hydrogen ions, meaning that not all the hydrogen ions are donated, that whatever that substance is, it is going to be a weak acid. Doesn't matter whether it's 0.000001 moles or 0.9999988 moles. Those are, as long as it does not completely donate its protons, it is going to be a weak acid. And fun fact for you is that because weak acids, in this case, since CH3COOH is a weak acid, we actually call CH3COO-, which is the ethanoic ion, we call it a conjugate base. And something interesting to note is that if the acid is weak, is that what is interesting is that hydrogen ions when hydrogen ions release, its partner is called a conjugate base. So in this case, CH3CO- becomes the conjugate base. In hydrochloric acid, Cl minus over here will be the conjugate base. And so it is with the sulfate ion. Something that my chemistry teachers used to tell me, if the acid is strong, its conjugate base is weak. If the acid is weak, the conjugate base is strong. And that's just something to take note every time you study acids, to being able to identify what is the conjugate base. So when you have a strong conjugate, now these questions don't really come out that often, so I'm not going to cover too much about that, but it's just something to keep in mind when you go on to higher levels, that there is such a thing called conjugate acid and conjugate base. Next, when we talk about bases, again, there are substances that can accept protons in the same way as the above. Strong bases accept protons completely, while weak bases accept protons partially. Now, is the easiest way to see completely and partially is to look at the arrow. If the arrow is one way, it is what we call as an irreversible reaction, meaning that this reaction goes one way, it doesn't go backwards. And usually for strong acids, it's always an irreversible reaction. For weak acids and weak bases, it's always a reversible reaction. Now we will go on to discuss reversible reactions later on, or whenever you go on to year 10 in a topic called chemical equilibrium, but we'll leave it at that for now. So let's take the example of sodium hydroxide, right, which is a strong base. When sodium hydroxide is exposed to hydrogen ions, being a strong base, it will be a one-way arrow. So what will happen is that we'll form sodium ions plus water. And you're probably wondering, why do we say that it accepts the hydrogen ion? It's because the hydrogen ion here gets taken in by the OH minus anion over here to form water. In contrast, when we talk about weak bases, the most common weak base that we usually use is going to be ammonia. And ammonia is always NH3. So ammonia reacts with hydrogen ions, it is going to produce the ammonium ion. So, however, as I mentioned, because it is a weak base, this is going to be reversible. Now, as I mentioned, if strong bases accept protons completely, it means that if you have 0.1 moles of hydrogen ions, you will form what you will have is 0.1 moles of sodium hydroxide will react completely with hydrogen ions to form 0.1 moles of water. However, in this case, since it's a reversible reaction, even if I have 0.1 mole of hydrogen ions, I'll form less than 0.1 moles of ammonia ions because it is a weak base. So that's the main thing about acid and base. Now, if we talk about the reactions of acids. For acids, ratio of acids, it's quite a lot actually. If acid plus base always produces a salt plus some side products. The thing is, it always depends on what type of salt you react it with. If it's an acid plus a metal, it usually forms salt plus hydrogen gas. Now, if you are year 10 or you have studied the metals topic, you will need to be able to remember which metals cannot react with acids. I hope you can tell me which 3 metals don't react with acids. Meanwhile, if acid plus metal oxide or metal hydroxide, it will produce salt plus water. Now, acid plus metal is just, let's say, give an example, hydrochloric acid plus, let's say, iron, or maybe not iron, acid plus zinc, you will form zinc chloride plus hydrogen gas. While acid plus metal oxide, let's say hydrochloric acid, plus let us say calcium oxide, or let's say nitric acid. Can't be using the same calcium oxide, go from calcium nitrate plus water. Or if you are sulfuric acid and you're reacting with calcium hydroxide or zinc hydroxide or magnesium hydroxide, you'll form the salt magnesium sulfate plus water. Finally, if you're reacting with a metal carbonate, you will form salt plus water plus carbon dioxide. An example would be if I were to use hydrochloric acid again, and I react it with, let us say, sodium carbonate, I'll form sodium chloride plus water plus carbon dioxide. As to how do I know what is the formula for carbonates, so the oxide is hydroxide, and how do I get these brackets over here? Again, if you have no idea how that comes about, I really recommend you to go back and check chemical formulas, because there's a lot of memorizing that you'll need to do. And of course, if you were here since July, I have given you an assignment to write out 48 equations on acid and bases, acids reacting with bases, so there is no excuse to not know how these reactions go. Finally, lastly, if I add acid plus ammonia, what I will form is an ammonium salt. So let's say I have hydrochloric acid plus ammonia, I will form what we call as ammonium chloride. Now, if you are my year 9s and you're listening to this either now or in the future, I really recommend that you actually look. I really recommend that you remember what I tell you, which is don't just look at the equations, but always think about the observations. If you do not know what your observations are, there's a good chance that these equations will just rotate to you. So very simple thing to note is that even though IGCSE never tells you to write down what the state symbols, I do still recommend you to do that because they are so very important. Because from the state symbols you can actually determine what are your observations. So for example, if we take hydrochloric acid plus zinc, what you see here is that zinc will then from solid becomes aqueous. This means that zinc solid dissolves in the solution, and because hydrogen gas is produced, you'll see bubbles form. And I hope you remember how to actually test for hydrogen gas. It's either a lighter spin or a glowing spin, and you cannot answer me that question, you're in trouble, right? So please, if you have no idea, please go and double check. In this case, again, for nitric acids, what you'll see is that these are aqueous, these are solids. If it's a metal oxide, metal hydroxide, there really isn't much reactions except that the solid dissolves, but sometimes you're actually able to see some changes. Perhaps if I were to give you an example, if I use this as iron, some magnesium, so in this reaction, your only observation here is actually that calcium oxide dissolves, and for sulfuric acid, well, they do dissolve, right? For sulfuric acid, iron hydroxide, iron, what you will see is iron hydroxide dissolves. But more importantly, iron sulfate, especially iron, is green in color gives a green solution because it's transition metal. So what you have to say is that causing to form a green solution. So these are really key things that you'll need to know as chemistry students, that you need to really understand that it is not just about writing equations or making sure you balance your equations or everything else. It's actually to make sure that you understand what actually happens in the equation. I'm not sure why is it giving me, I should put it as 2 dots, I guess. Oh well. And this will be a 3. And finally, in this case, ammonium doesn't really produce this case for acid plus metal carbonates. I'll give you, you know what, I'll give you guys the observations, and I hope that you can tell me what actually are the state symbols. First thing is sodium carbonate dissolves. Gas bubbles are produced and turning lime water. And for people who like the word milky or cloudy, I do not discriminate. I usually use cloudy myself. So in this case, ammonia is, depending on the case, can be aqueous or liquid. So in this case, usually you do not see much happening. So acid plus ammonia is usually a bit of a conundrum. Meanwhile, so that's reaction of acids. Now let's go down to reaction of base. Right? Now reactions of base, honestly, because bases are metals, metal oxides, metal hydroxides, metal carbonates, and ammonia, there really isn't not much reaction of bases which is very specific to bases, except one. When you add a base plus an ammonium salt, what you get is that you get a different, what you'll find is that ammonia is produced, for one. A different salt, new salt will be produced, plus water, plus ammonia gas. And this has to do with what I was talking about, being about about conjugate acid and conjugate base. The thing is, you see, just as ammonia is a weak base, right? Ammonia is a weak base. However, ammonium itself is the what we call as the conjugate acid. And because, and remember what I said, when you have a weak acid, you have a strong base. You have weak base, strong acid, you have a weak base. In this case, if you have a weak base like ammonia, NH4 plus X as a very strong conjugate acid, meaning it's most likely going to donate the hydrogen it has accepted. So when this happens, so giving any example, right? Let's say I give you sodium hydroxide plus ammonia, plus ammonium salt, let's say ammonium bromide. What you'll see is that ammonia gets kicked out pretty much to form sodium bromide plus water plus NH3. So what you see here is that sodium hydroxide, because it's a strong base, it displaces the weak ammonia, the weak base of ammonia from its salt solution, kicking it right out of the ballpark and causing it to turn back to ammonia gas. Now again, as scientists, we must always think about what is the observation. The observation is most likely you will see a brown gas produce. What yours and can be tested turning, I think it's brown gas, I can't remember. What you will see is gas bubbles produced, turning damp litmus paper blue. And well, honestly, that's the main reaction. So that's reaction acid base. So let's just quickly stop over here, right, and just see what's happening. So yeah, I mean, alright, let's just quickly scroll down. Ooh, some people just went completely, going completely OP in the chat. So hey, heads and shoulders, Jacob, Beach, Jacob, DJ, and then so looks like Jacob got hacks. It looks like, so some of you guys are asking what is conjugate base. So essentially when you see, and let's see other things over here. So why on earth do I have Terry Long? Hey Terry, hopefully you're doing well. And then you have Matthew Sim saying hydrogen the gold. I mean, hey Matthew, I hope you. So Matthew's a big, the goat himself of 2023 has dined to honor me with his presence. What's up? What's up? Hope that you're not suffering too much. Are y'all gonna fail? Well, hopefully not likely. And yeah, it is the easy. I'll say chemistry at this point is pretty easy. And Matthew is just going all crazy. Chat. So yeah, I mean, why I actually don't really I'm just managed to get into the chat, guys. As I said, I'll try and check it every time I finish a sub chapter, so I don't usually read it as much. But yeah, I'm back. I'm back right now. Probably I am somewhere like over here. Probably a few more minutes before you catch it. So I'm just gonna sit around and just wait for any questions that you guys might have. And I'm gonna play a little bit of soft music while we're at it. Hopefully soft, right?
Liftoff of mission 41B, the first flight of the orbital Discovery, and the shuttle has cleared the tower. computers now have primary control of critical vehicle functions.
I think everyone's caught up right now, so just gonna wait for the questions to come in. I think I'm waiting for about 3 minutes. We're about to be 5 minutes. Alright, let me just demo slightly. I see people asking what is acid. Let's see. What is conjugate? So Jacob's question on what is conjugate based or what is conjugate is actually when you, if we were to look at acids and bases, right? So when an acid reacts, let's say hydrochloric acid in in this example, right? So HCl, hydrochloric acid, what happens is that it will release all this hydrogen because it donates the proton. So basically imagine it's as if HCl breaks up, right? HCl, chlorine, the chloride ions lets the hydrogen go. And just going to reduce a bit more, bit down to absolute zero. So hydrogen ions, the proton is donated. What's left behind is the chloride ion, and the chloride ion, because it used to be a partner of the hydrogen ion, it's called its conjugate. Now conjugate, you can kind of think of it as its partner ion. And in this case, because, and it's usually called the conjugate base. Why? Because if we were to reverse the reaction, chloride would take back hydrogen and form hydrogen, HCl, hydrochloric acid. So in that sense, because when the reaction is reversed, chloride will reaccept hydrogen. So if we were to look at it backwards, it will become chloride plus hydrogen. I mean, it doesn't actually happen, but because if we have to reverse the equation, it will mean that chloride accepts hydrogen back to form HCl, and because in the reverse reaction, chloride receives the proton back, thus we call it role will be of a base. So the base refers to the partner ion or the partner ion that the partner ion of hydrogen for acids. So for hydrochloric acid, it's going to be the chloride ion. For sulfuric acid, it's going to be the sulfate ion. For the ethanoic acid, it's going to be the ethanoic ion. Meanwhile, for sodium hydroxide, in this case, since the hydroxide is the one that accepts water, the sodium ion will act as a conjugate acid. In this case, ammonium ions act as a conjugate acid because there is no other. In this case, ammonium ion acts as its own conjugate acid because it only produces one ion itself. In addition, so that's what conjugate is. It's not as big of a thing, but I think if you go on to A levels, like where magic is, then you'll probably appreciate a little bit of the conjugate acid and bases. Meanwhile, let's see other questions. I mean, hydrogen is a really good question, really important thing. In the reaction, I mean, that's why we are hydrogen oxygen fuel cells. You said you have a lot of questions, like, I'm still waiting for the questions, honestly. What is a compound? Compound is basically any two atoms of different elements, mainly different elements, combined chemically. how to know what are the observation color, and if for Kaijun, how do we know what's observation color? You have to kind of, the main colors that you need to remember is iron. Iron is Iron 2 is green in color. Iron 3 is reddish brown. Um, Copper is bluish in color, is blue in color. Chromium 3 plus is green in color. And yeah, those are the four main ions that actually have any color itself. So I'm just going to take a very quick 5 minutes break to the toilet. In the meantime, just drop your questions in the chat and trust you guys are surviving. Stay hydrated, guys, and when I come back, we'll spend a bit more time asking on salts. you sometimes do see a flash of pink very rarely. I think especially when we're talking about like most methods, it's going to be gray, silver, depends on the method. At the same time, also like when we're talking about electrolysis, just because atoms form an electron, you have to kind of think about what atoms usually are formed. Usually it's metal atoms, very rarely will it is any non-metals. So yeah, I think that these are so usually when you see is an atom is usually the cathode and it's usually the copper, it's usually the metal that gets deposited, so the you see the latch will kind of get thicker. I think in terms of I think these are very good questions that are asked, and it's also important to remember what colors. So as for the question of whether gas atoms got color by potato, you have to remember the specific colors, especially of halogens, because there are two specific gases in halogen that have colors. But you also need to know sulfur dioxide color of other gases. Sulfur dioxide, I remember there's color, but I'm not sure. You have to double check. And nitrate is cool up though. Give me a minute. Let me just lower it down to a little bit. Okay. This I think this is much better. So I'll say that let's just okay think on my side. So there are certain gases color, but most of the gases that we have are just gonna be how do we say going to be colorless most of the time at least. That's a very good question. How do we I'll need to double check on how my system actually works to actually see how you guys get XP, because I have no idea how people get XP. Of course, I do this just for chills and stuff. Alright, so just gonna load down the music over here. We're gonna go, and we're just gonna continue a little bit longer on salts, and when I say a little bit longer, it's probably gonna be pretty fast. So as we're talking about acid and bases, we always often have to talk about salts. And I actually do wonder what is the definition of salts by your teachers, by the teachers that taught you before. For me, I would like to say that salts are ionic compounds. They are formed from either the reaction of an acid and a base. Acid and base reactions are often called neutralization reactions. So sometimes you'll have to be a bit aware that when you say neutralization, it's not just acid and alkali, it's acid and any base, or from a precipitation reaction. Now, salts are ionic compounds, so they will exhibit every other feature of an ionic compound. But what is most important thing to know about salts is, number one, is the salts, which are soluble and which are insoluble. The reason why you have to understand this is because for certain salts, there are 3 different ways to prepare a salt, and if you use the wrong method, you're gonna have a hard time trying to get the pure salt crystals out of it. So let's start off with different types of salts. Salts and solubility. Now I'm going to put these 3 in a group of their own, the SPA salts, which stands for sodium, potassium, and ammonium. When I talk about salts with sodium, potassium, ammonium, I'm talking about any salt that has sodium, potassium, and ammonium as a positive ion in the compound. So these are always soluble. Because of this, they are prepared by the titration method. And only sodium, potassium, and ammonium salts are prepared by titration. Next, if we look at nitrate salts, sulfate salts, as well as chloride salts. I don't think I've left out any of the other salts. Hopefully not. So nitrate salts are always soluble. Sulfate salts are always soluble, except for three salts. Three salts. First one is Pb. That is Pb, Ca, and Pa. So lead, sulfate, calcium sulfate, and barium sulfate are insoluble. For chloride salts, all are soluble except for calcium chloride and silver chloride. Now, all other soluble salts are prepared by filtration of excess base. Now this method, while all insoluble salts are prepared by precipitation. Now if you want to have a better understanding of how filtration of excess base, titration, and precipitations are done, please go to my channel and try and find that one of my flipped classrooms in the last term, where I taught in detail on how do we actually do the 3 different methods of salt preparation, and that will probably help you in how to actually prepare these 3 different types of salts. Now when we talk about filtration, so when you're preparing any type of salts, always ask yourself, first thing first, is it a sodium, potassium, or ammonium salts? If it is, then you'll use the titration method. If it's an insoluble salt, you use precipitation, and if you use doesn't fall into either category of insoluble salt or sodium, potassium, or ammonium salts, they are going to be prepared by filtration of excess base. The third thing to know about salts is what we call as water of crystallization. They refer to water molecules that are chemically part of the crystal of this. And the most 2 famous ones, 2 salts that are hydrated, they have water of crystallization, is cobalt 2 chloride and copper 2 sulfate. In their anhydrous state, meaning where they have no water they do not have water in their crystal, but this cobalt chloride is pink in color. It's blue in color, in my view. The copper 2 sulfate is white in color. When it's hydrated, it turns pink, and copper sulfate turns blue. To make hydrated salts from anhydrous, just add water. Observations, often at times, you're going to see heat produced, water vapor is released. This is because we call this reaction an exothermic reaction. And to make hydrated salts, anhydrous salts from hydrated, you heat the salts strongly. An observation here you will see is that condensation occurs at the mouth of the container. Now, because you heat it strongly, it is itself an endothermic process. Now, most people have a little bit of a hard time, especially when they're doing salt preparation. And a lot of people have trouble when it comes to what we call as constructing ionic equations, especially when we're dealing with inorganic salts. So, to give you just a very quick example of ionic equations, right? So, if we take this example, so just going to show you an example of a past year paper. So in this case, right, we mentioned barium sulfate. Barium sulfate is an insoluble salt made by precipitation. Now, it's important to note that you want to form barium sulfate. In order to form barium sulfate, you need two aqueous solutions, meaning you need to have an aqueous solution 1 plus aqueous solution 2 will form barium sulfate. Now, some of you may do the dumb stuff and say one of them is obviously barium sulfate, duh. But just think about what you said, because we just mentioned that it needs barium sulfate is an insoluble salt, meaning that and barium sulfate being an insoluble salt means it cannot dissolve in the solution. So we need one solution to have barium and the other solution to have sulfate. And the easiest way to do that is always to use the ions that are always soluble. So in this case, I use sodium sulfate and barium nitrate to form barium sulfate. Alternatively, can I use potassium? And I also can use ammonium. Why? Because all ammonium, potassium, and sodium salts are soluble, and all nitrate salts are soluble. So they make very good what these ions, ammonium, potassium, sodium, and nitrate, they make very good spectator ions. Because barium sulfate here will be solid, and what will be produced is sodium nitrate. It's going to be aqueous in the solution, meaning that we can immediately filter it out. So just to write out, this is the word equation. I hope that you will always take into account the how to write the simple equation, because that is very important. So name two aqueous solutions and tell me sodium sulfate or potassium sulfate or ammonium sulfate. Either one is fine. And tell me barium nitrate. You could even use, you could also, actually there is one more, right? You can alternatively use sulfuric acid, because sulfuric acid is also always soluble. Now, how do we produce a pure sample of barium sulfate? If we look at the equation, aqueous sodium sulfate reacts aqueous barium nitrate to produce solid sodium barium sulfate and aqueous sodium nitrate. It is the only solid in three aqueous solutions. It means that all that we need to do is filter the solution, rinse with distilled water to remove any other soluble salts, and then dry the filter paper. You can also dry in the oven, up to you. Now, many people get stuck on the ionic equation, and it's actually very simple. First thing first, you'll write the salt over here, the salt that you want to make, which is barium sulfate. is solid. You might have to remember because it's an insoluble salt. Next, you write the two ions that you want to use, which is going to be barium ion and sulfate ion. And these two ions are going to be aqueous. Why? Because if we look at the equation above, their salt solutions are aqueous. So you just copy that. So barium ions plus sulfate ions will form barium sulfate. 1 mark is given if you get the two reactants correct, 1 mark is given if you write this correct, 1 mark is given if you write all state symbols correct. Now just because I know you guys do not know how to do this, and I do not trust you to do this, let me show you another example. Let's see if I can find it. Alright, in this case it is lead 2 chloride. So again, lead needs to be paired with something, chloride needs to be paired with something. Easiest thing, sodium chloride. Or if you don't want, potassium chloride. Or hydrochloric acid, up to you. Here, lead, easiest thing to do, lead to nitrate. And for this, I recommend you just keep to nitrate. Because with lead to nitrate, you'll never go wrong. Now again, they want the formation of lead 2 chloride and the ionic equation. So let's write out lead 2 chloride, right? So the final product is lead 2 chloride here, which is solid. The two ions that form it is lead 2 plus aqueous plus Cl minus aqueous to form lead 2 chloride. Now in this case, because there's two Cl chlorine molecules here, but only one here, you'll need to balance the equation. And again, the steps is very simple. Filter the solution, rinse the residue. Important to note, rinse the residue with distilled water, which I failed to mention there, and dry. You filter paper or in an oven, really depends, up to you. And that is how you always score marks on questions regarding insoluble salts. And that's actually all there is to it on acid and bases. Acid, base, and salts, which is a very chunky topic, is a very chunky boy, but it's very important that you know how to answer these kind of questions. For observation part, can I say what is formed without saying the color? You can, but it's always good to be specific to answer Pang Jun's question. So yeah, I'm just gonna, so with that actually clears up acid, bases, and salts. And now I just open the floor to questions if you guys have. Well, if there are no questions, I really thank you guys for watching. As always, if you're not subscribed to the channel, please do hit the like button and the subscribe button so that you know every time I'm going to be live. I don't go live that often, but hopefully, I think at the end of the year when I get things sorted, I'll be able to do a few guides, especially in terms of in light of the um, highlights of the winter papers, as well as a bit of like reflections on the papers, as well as maybe as the holidays come in, maybe I'll do some gaming streams. Light gaming, by the way, my computer cannot handle it. So yeah, thank you guys for watching, and as always, I'll see you guys for those semesters. I'll see you in school. So bye bye. Stay locked in, and always enjoy matcha.